try to understand concept with the help of this diagram. So this has the slow start phase here. Then we have congestion avoidance, and then we have this timeout event, and then and then we see how we gonna retransmit and adjust our sending rate. And hopefully this should answer all of the questions that we raised initially at the start of the lecture. So, by the way, there are different TCP variants, and at the moment I'm talking about TCP Tahoe. Okay. So what happens here is that we start with maximum segment size. So this is the congestion window, and these are the number of transmitted segments or transmission rounds on x-axis. So remember, the initial congestion window size is, yes, you're right, 1 maximum segment size. So initially we transmit 1 maximum segment size, and upon its receiving its acknowledgement, we double the congestion window size. Now we will be sending how many number of segments? 2. Upon receiving the acknowledgement, cumulative acknowledgement for this segment, we will be sending 4 segments. So congestion window size is now 4. And upon receiving cumulative acknowledgement for these 4 segments, I will increase the congestion window to 8. And upon receiving cumulative acknowledgement for these transmitted segments, I will increase the congestion window to 16. So here you can clearly see that this increase is exponential. 1, 2, 4, 8, 16. And now we have reached to threshold. Let's assume that the threshold was, for this example, yes, we know that initial value of the threshold is, the slow start threshold is 64 kb, but just for the example, let's assume that we have reached the threshold, and threshold was 16 segments. Okay, so this threshold is, obviously, we know that this is slow start threshold. Okay, so size is 16. So this is what? This is the initial phase. Remember, we said TCP has the slow start, additive increase, and multiplicative decrease. So this phase is representing the slow start. After reaching at the threshold, now we will be increasing the congestion window size linearly. Okay, I mean additively, and this means we are in congestion avoidance phase, right? This is additive increase. Additive increase. Okay, and you can think of this point as the system is operating at need. Okay, so now we will be increasing a congestion window size linearly. Upon receiving the acknowledgement at this point, the congestion window size is 17. Upon receiving acknowledgement, cumulative acknowledgement, the congestion window size is 17. Again, receiving acknowledgement, the congestion window size is 18. And now, after receiving the acknowledgement, congestion window size is 19, and then congestion window size is, say, 20. And let's assume this is the cliff, right here. I mean, this is the point where we experience a timeout. Here, the RTU has expired in wait of an acknowledgement. So what we're gonna do is, so first of all, straight away we would adjust this threshold, the slow start threshold, by dividing the congestion window by 2. So what was the congestion window size here? Yes, 20. And now we'll divide it by 2, and the new threshold is 10. And we'll again go back to slow start phase. Means we'll start with congestion window size 1, where the congestion window size is 1 maximum segment size. Upon receiving the acknowledgement, we'll again increase the congestion window size to 2. Upon receiving the cumulative acknowledgement, we'll increase the size to 4, then 8, and then 10. And then again, we will try to probe the network, the bandwidth or the pipe here. Okay, so this is one way we can trigger retransmission. But there's another way where we can trigger retransmission, and that is upon receiving triple duplicate acknowledgement. So if we're receiving triple duplicate acknowledgements, so this means we will not wait for the timer to expire, and we will immediately do the same thing. That is, uh, we'll do the multiplicative decrease. By the way, this step here, this step is known as multiplicative decrease. Okay, right. So we have decreased the window size or the threshold by dividing the congestion window size by 2, and then we are into slow start phase again. So we do not wait for the expiry of the retransmission timeout, and immediately upon receiving triple duplicate acknowledgements, we reduce the slow start threshold by dividing the congestion window size by 2, and then we again enter into the slow start. But there is a problem with this approach or with this TCP Tahoe. That is, this we are not really uh, filling up the network pipe or the bandwidth. Even in the case of this fast retransmit, this upon receiving the action upon receiving this triple duplicate acknowledgement is fast retransmit. Okay. There's still we are wasting the bandwidth because to a loss of segment, right? Yes, we are sending it fast, but still it's not, filling up the network pipe or the bandwidth efficiently, right?